So, hey everybody, it's Sofox again with another Arduino Starter Kit, this time number 10, Zoetrope. Now, on our last episode, we got a motor going. Oh, right, yes. Gotta have it plugged in. Nice. Now, as I told you, this spins, and what's more, it spins in one direction, and if I want to spin in the other direction, I just reverse the, unplug this. No. Point is, I just switch these two together and just reverse the polarity effectively. But what happens if I want it to be more dynamic than that? That is where the H-bridge comes in. The H-bridge is actually very, very fancy. Now, previously, I showed you how we had this transistor. This transistor let us use one electrical current source to channel. Basically, we've got two power sources, one from the computer coming in through this cable and one from this battery. And therefore, we needed a transistor so we could have a switch that switched this battery on and off to spin the motor. But the question is, what happens if you want more complex control? What if you want to make it go one direction, the other direction, and off? Well, you could set up a huge amount of transistors in a complex pattern in order to achieve that, or you could just get a H-bridge which does all that for you in a nice little integrated circuit pattern. Now, H-bridges, as you can see, have a lot of pins. It's almost a little daunting, but don't worry, you just have to wire them up in quite the right way. The key thing is, essentially, they've got a nook on the top, and the pins are 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, and then you switch to the other side and go up the other direction, 9, 10, 11, 12, 13, 14, 16. I always found this numbering system a little confusing, because I was like, you know, shouldn't it go like 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14, 15, you know, both top down? But no, apparently you go from the top, go to the bottom, and then switch sides and go back in the reverse direction, and, you know, it's standard, industry standard now, so no chance of changing that. Maybe there's a reason for it, who knows. The key thing is that this H-bridge replaces the transistor because it's already got transistors. So with this H-bridge, we say bye-bye to Mr. Transistor. We'll unplug the battery pack because we don't need it right now. And yeah, I think we don't need the diode as well. I believe I think the H-bridge takes care of all that sort of like diode stuff. So, what are we actually going to be making with this H-bridge? Well, like our last exercise, it's going to have the battery and the motor. And this time we're going to make a Zoetrope, which is, it's kind of hard to describe. I'll just switch the photograph. Yeah, it's something like this. It's basically an animation system. Instead, by the power of just this card and a spinny thing, you can look into it and see an animation with your own eyes. And this is long before television or, you know, cathode ray tube TVs or film strips or anything. This is one of the earliest forms of animation. And because it's so easy, that's one of the reasons we can make it. Well, easy as in straightforward. So, after I unplug this Arduino so that I don't accidentally blow a few wires up, how do we wire this up? Well, there is a lot of wiring in this, but let's try to take it one step at a time. So we've already got a switch, and we put in a second switch, and these will help us control the speed of the of it. And also we've got one other thing. We've got a potentiometer here. There we are. A potentiometer, as I've said, is basically a variable resistor. Damn it, hang on. There we are. Okay, and hopefully it's not too close to the button. Well, if it is, I'll just have to move the button because potentiometer... screw it, I'll move the button. There we are. There, close enough. Button, potentiometer. So potentiometer is basically a voltage divider. You know, you've got voltage, negative, and if it's turned all the way one, this pin over here will either be connected to the top or the bottom or somewhere in between, depending on how much you turn this dial. So do touch that dial, because that's how this whole thing works. Okay, we use ohm resistors here. No. I'm almost confused about how this whole thing works. Oh yeah, we should probably put in the H-bridge as well while we're at it. Yeah, that looks good. And you obviously put it across this little divide here, because that way, hang on a sec. Oh, damn it. You got to put it across the divide, otherwise you'll accidentally, you know, if I put it here, then the top 2 pins would be connected in the second top, and it would just be messy. You got to keep all the pins separate from connecting unless you specifically want them to be connected. Okay, and I got to make sure the notch is still at the top. There we are. It's in. Okay, so time to make sure these resistors are still 10 kilo ohm. Yes, 2 10 kilo ohm resistors, and they go from the bottom of the switch to the negative of the battery, and the same here. And we're still connecting the two at the we're still connecting negative here with negative here. That is still a thing that's happening. And the positive goes to a bottom left of this of the H-bridge pin. And apparently the positive of this motor goes to not the third pin. Okay, hang on, I got this in the wrong slot. It's there. So the positive of the motor goes this pin up. Okay. And we connect the second from the bottom left pin with number 2. Okay. We connect, yeah, so it goes, the very bottom left pin is in positive, then we get to this pin which connects to number 2, that's obviously control pin. This one connects with the motor. The next 2 pins connect with ground directly. Okay, and then we connect the second from top pin with pin 3. Wait, sorry, that's pin 3. Wait, what? No. Yeah, pin 2. This isn't pin 2. This is pin 2. There's pin 2 and still goes there. And this is pin 3. And that goes second from top on the pin. And the top left pin goes into pin number 9. Okay, so that's enough there. And okay, meanwhile, one end of the potentiometer gets hooked up to ground, and the other seems to get hooked up to, yeah, up to voltage, which is kind of what I expected, but just always good to double check. That's one end to ground. Other end to voltage. No, wait, wrong pin again. Okay, and the other one goes to A0. The middle one goes to A0. Obviously, that's, yes, A0 is about sensing, so that makes sense. We've got, this is just a simple detection thing that detects which value this is at. So I've still got to wire up these switches, and the positive in both pins and the negative to 4 and 5. Yeah, that's already hooked up to positive. This one should also be hooked up with okay, that's positive. Negative is to both pins. As you can see, they're both, yeah, through this grounder thing they're hooked up with. So their positive goes in this side, negative goes at this side, and if we connect it here, it'll be like connecting it there. So that just, trust me on how that happens. So that goes, yes, 2, 3, and 4 and 5. So 4 goes in here, and and the other one goes here. Oh, right, and I accidentally broke this in the process. So yes, this goes here, this goes here. So 4 and 5 are hooked up to these two buttons, that's fine. A0 is hooked up to this potentiometer, which is also good, so we can measure the two buttons in the potentiometer. The H bridge I'm a little less sure about because there's so many different components. What's very clear is, oh yeah, there's one thing. Everything we've got is hooked up on one side here. What we do know is it's got 9 and 3 all. It's got 9 and it's got 3 pins hooked up to it. A 9 hooked up to the top pin, a 3 hooked up to the second one from down, and 2 hooked up here. That's 3 pins hooked up to it. Also, this battery, this voltage thing is coming out of it. So that means that that's hooked up there. It's hooked up, the voltage is hooked up there. No, wait, I've got this wrong. I put the battery into the H bridge rather than the actual motor. That was a dumb move. That was a very, very dumb move. I hope I didn't damage it. Hopefully not. But yes, there, the motor goes there and there. So, the H bridge has got power going into it. It's got two things that are, it's got 2 of its pins are always permanently stuck on ground. I believe there's all a data sheet that explains how this controls this. And we've got 3 pins controlling 3 of the other pins, and there it is. The only thing that seems to be missing is another form of ground. Ah, yeah, there we are. We're missing one more sort of ground. Obviously, pulling the pins to count doesn't count. So the voltage is coming in from the battery, and the ground, it doesn't matter which the ground goes because the two are connected. So, top left pin goes to, I think I'll get a smaller one. So, that's ground. And the top left one also goes to ground. So let's go through this again. Switch buttons, switches, H bridge. H bridge is directly hooked up to the motor. There is nothing else hooking this up. It's as simple as that. The H bridge. There's no resistors. There's no transistors. There's no diodes. It's all directly this. Everything else is hooked up. Basically, the H bridge is powered directly by the battery itself, and the ground is obviously shared between the two, so that doesn't matter. Which means that this H bridge is getting the full power from the 6-volt battery once I plug it into the actual terminals here, which I think I might as well do. But it's probably going to get detached before I get in, because these wires are very loose. I'll get back to that. The point is, the H bridge is powered directly by the battery. It's hooked up directly to the motor. 3 pins are controlled by the microcontroller, and remaining 2 pins are pulled to ground. Now you might notice that, hey, it's all the wires on this side. What about this side? Well, I can skip ahead and give you the explanation. It's kind of mirrored, so you can actually set up a completely separate motor on this side just by doing similar things with the wires and wiring them all up. So the idea is that, yes, you can control 2 motors at the same time with this, and it'll still be off the power source. But the key thing is that this H bridge will be controlling this motor through the battery pack power source. It will not be controlling it through the Arduino itself, which is great because the Arduino doesn't have as much voltage and definitely not the amps drain. So you can see a lot of little stuff placed in your breadboard. So with things, plug the battery connector, blah 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 blah. So that's all well and good, but now we have to get to the real part, and that is the actual code. Now, unlike previous chapters where it was basically just sensing Unlike previous chapters where the code was kind of simple and straightforward, in this case it's a little more nuanced because the actual code is controlling the thing itself. It's not just, this is where the bulk of the work will actually take place. See this previous thing? Oh, that was just one switch, and depending on how the switch is, we change the output. Nope. It's going to be far more complicated than that. But fun. Yeah, exactly. So this is, we've got our Zoetrope. And let's begin. So, this is the control pin 1, which of course is one of the ones. So, we've already explained that yes, there were 3 pins. 3 pins are going into this thing, and those are the pins. 2 control pins, and 1 is enable. From what I recall, enable is basically whether it actually goes or not. So there we go there. On, off, switch, stage, switch, pin. That's a mouthful. It's got switch in there twice. Even I rarely complicate my names like that. Well, at least the pop pin I know. So obviously those are the 2 buttons and the potentiometer. Yep. So 3 pins for the 3 pins for input, 3 pins for controlling the actual thing. So it seems like one of the buttons is whether it's on or not, and the other is which direction it's actually going or not. And because we're checking the previous state, that means that we detect when it changes from one to the other. So pretty straightforward, whether it's running, speed, and direction, yes, for the motor. As you can see, pretty much setting up the inputs and outputs. The only input we haven't set is the potentiometer, because I believe that's set up already. Oh, all right, wait, there's one thing. So, that makes sure that it's disabled to begin with, I believe. So, on, switch. Every loop we have to read the states of all the pins. You know something? Autocomplete. That would be a really nice thing to have in this IDE. Read. So as you can see, we just read, I don't know why there's a delay there, but we read the on-off switch state. We read the button, whether the on-off button is pressed, whether the direction button is pressed, and you know, depressed more specifically, and also, you know, get the where the potentiometer is, and divide it by 4 to get a value that's, you know, between 0 and 255 rather than 0 and 1024. So first of all, let's check to see if the on-off button has been switched. If on it does not equal previous on state, if on off switch equals high, then motor enabled equals not motor enabled. So what this basically does, no wait, that's about right. Okay, so what this does is, obviously if the on-off button was pressed and not pressed, it's changed. But we need to check whether whether it's gone from low to high, i.e. when you pressed it or released it, because otherwise you'll have something that when you press it, it says it's switched, but if you release it, it also says it's switched and does it both. So the idea is every time it goes from low to high, every time you initially press it, the motor gets enabled, or it's toggled from on to off. So the idea is you press the button, motor, if the motor's off, it goes on, and then you press it again, and if the motor's on, it goes off, so on, so forth. And oh boy, I'm just kind of like going to copy and paste this, because seriously, direction switch state and previous. Where's previous? Yeah, previous direction switch state. So yeah, and that's motor direction rather than the other thing. Interestingly, so the exclamation mark basically makes it the opposite. So that's how that one works. So if it's 1, it goes to 0, and if it's 0, it goes to 1. If motor direction equals 1, digital right control pin 1 high, digital into low. Now, like I said, there's probably documentation you can get for all the signals you can put in, but as you can see, this is how the direction works. You set pin 1 to high and the other to low, and it goes in one direction. And okay, let me just switch this with an else. Yeah, then you just have to switch it for the others. So that's going to choose the motor direction. I gotta do it. If so there's a lot of code here, but it all works. A-N-A-I-O-G-W-O-R-T-E enable. Okay, so we've already, so just to quickly clarify, this one here is where we read, here's where we get the motor speeds, whether the motor is enabled and the motor has a direction. One is from the potentiometer, the other two are from the buttons. Here is where we set the motor direction. Here is where we set them by digitally writing the pin. Here's where we set whether the motor is enabled. If it's set to 1, then we set the enable pin to the, then we do an analog write. So as you know, analog is actually able to like vary the voltage, so it's not quite, you know, therefore, so it's not just a 1 or a 0, it's actually a varying value. And if it's set to else, analog write enable pin, and I'm pretty sure it's 0, yeah. So if the motor is enabled, we get 3 values: direction, motor speed, and whether it's enabled. We read those. If depending on the direction, we set the control pins that control that, and whether it's enabled. And if it is enabled, then we set the enable pin to an analog value that's equal to the motor speed. Otherwise, we just set it to 0 straight out. And now for the parts that we make sure, previous direction switch state equals direction. This is where we actually set the previous value so that for the next loop they're preserved. I am so glad that, okay, there are so many long name variables here. I can't wait to see how much of those I've completely misspelled. Okay, direction, capital D by accident. Okay, which, pervious, no, previous. Only 2, not bad. Not bad at all, actually. Okay, so I think that's the last of the code, so we need to actually make sure that this actually runs like it's meant to. Yeah. All right, let's hide this. Let's hide this source code and just focus on the actual thing itself, as they say. And I just need to double check to make sure I put in the battery. Yes, red goes on left, black goes on right, just like it's lined up. So we've lined up the, we've applied the battery, and now we just need to plug this in, and then, oh yeah, I'm just going to quickly, I've validated it, and I'm going to upload it. As you can see, it's blinking as it receives it, and it's finished. So, oh boy, moment of truth time. There's so many complicated bits. If either one single bit is going wrong, I'll have to debug and try to figure out where the error is. But when I press this button, this motor should start. Maybe this button. Maybe the potentiometer is at the wrong value. Congratulations and welcome to Sofox's debug time, where we get to debug cool oh, for fudge's sake. Maybe I should just make sure these are in properly. Honestly, not being plugged in can actually be a surprisingly common cause of not working. Okay. Alright, I better put this mile value. Okay. So what we got to do is figure out where in the process everything is going completely pear-shaped. It could be any number of factors, to be honest. We definitely have that worked out. We've got this hooked up here, and we've got that worked out there. We'll have to take a look at the software and the serial monitor. Okay, here we go. This will just let us know whether the buttons at least work. Okay, the bottom button does, which is fine. That's the direction button. The top one is not returning any results, which is actually good, because that means that we've limited it down. Because if the button is not on, then obviously it's not going to pick up anything. So let's go back to the circuit diagram. Okay, so this says we need to plug this cable into number 5, but for some reason it's plugged into number 10 instead. This is probably what's causing it. This button is literally wired up to the wrong pin. So we take this, we stretch it out, and we stick it here into pin number 5. So theoretically, I shouldn't even need to recompile it, it should just work. Oh, except for the fact that the battery is fallen out, but there we go. I mean, the only thing I'd want to change is getting rid of the print statements, but who cares about that at this stage? Okay, let's see. Okay, it looks like Sofox's debugging hour is not over yet. So first of all, let's view the serial monitor one more time. Let's also recompile for no apparent reason, and now let's press the buttons this time just to see. Okay, so the buttons are now definitely working. Okay, so that's good. That's good. That's nothing wrong with that. I might as well serial print line the actual the pop pin value actually, just to make sure that works. Okay, so now it's 9. That's weird. I mean, it's... The weird thing about this... Oh, sugar. Yeah, okay, I made another mistake here. You can see that I wired it up in the diagram, like I said, the middle one going here. But I forgot that, yeah, because of how the pot is, the middle pin is on the other side. And, like over here. That's just... Basically, like I said, my potentiometer is wired differently from the diagram. And when I did that, I accidentally unplugged this again from number 5, was it? Okay, that's back in 5. So, if I move this, yeah, there we are. So, I moved it back, and I'm getting back to 255 now. So, that should be the inputs. The inputs should be working now. So, what's wrong with the outputs? What would follow would be 15 more minutes of pure debugging. I tried a lot of different things. I tried adding more print statements to see if the code worked, going over the wiring one more time. I tried hooking the inputs directly to plus negative to try to make sure that the values weren't being messed with. I also tried actually replacing the entire H bridge because I thought that it had been burnt out by the battery. Eventually, I went online and after finding the wrong documentation, typed in the part number for the H bridge and managed to get some pure documentation for how this thing is meant to work. So here's the data sheet for it. As you can see, 1 and 2 is enable, then A and Y and 2 Y and A. So A is the driver inputs and there are the driver outputs. So yes, the outputs are on this thing. VCC 1, VCC 2, so these are the 5-volt supply and the, there's one of them is supply, one of them is power and the other is drain, I think. Yeah, I think so. I got this the wrong way around. No, yeah. Yeah, the top right is definitely to power. Wait, what? No, yeah, the top right is to... Wait, what? No, that makes no sense. Hang on a sec. Looking at this diagram, they have the top right and they have it going to plus. Why does they have it going to plus? I thought this was going... Oh, shit. Sorry, excuse my language. Okay, the plus of the battery is going to the bottom left pin, but the top right pin is going to the plus of the other one. It's not going to the negative. I've got this hooked up to the wrong pin. Okay. That's what it is. This should not be... One of them is hooked up to the plus of the battery, which is fine, and the other is hooked up to the plus of the pin. So, I take this out of here, and I put it in here. And of course, now it's working. Because I put it into the wrong thing. This is the negative, but this isn't. Ooh, is that hot? A little. And it works. So, we need to see if this actually works now. So, enable, stop. Oh, sorry, hang on. So now it works. Okay, so let's get rid of this IDE, which is pretty silly now, but there you go. Now the potentiometer goes to the... changes the voltage to the AE pin. This one starts it and stops it. Stop, start, stop, start, stop, start. This changes the thing to the enable, whether the enable pin is 0 or not. And this one shows out how big or small the enable pin is. So the 2 pins here are controlling the direction. So I'll try to go to a slower speed and see if... Okay, so that's a pretty slow speed. Okay. Okay, so I have to go fast because somehow it stalls if I change it like that. So as you can see, each time I press the change direction pin, it changes direction because it's a good boy. enable stops and starts it, and potentiometer obviously changes the voltage, you know, when it's still inactive. So there's your answer. That was what I did wrong. I accidentally hooked up one of these pins to the, basically this H bridge needs one connection to the positive of the battery and one connection to the positive of this thing here. And I'm not sure why, but it worked, so whatever. And of course these middle ones are just always meant to be connected to ground or some description like that. They're heat sinking ground, which is good because this is getting a little warm. So this is completely, but I still owe you guys a Zoetrope. Now because this is going to involve a bit of craft work, you'll have to bear with me Okay, so I've got this back together again. We've got the pinwheel, but we need more than that. So we need to get this thing here and slot it in here, and we probably need to secure it with glue or something that I'm not going to do because whatever. And then we need to just get this going here, and then we insert these into the tabs that are here. God damn it. Okay. Okay, I've got most of them in, but as the song goes, 3 out of 4 ain't bad. And any resemblance to a carnivorous plant, apparently. Absolutely no resemblance whatsoever to any property attached with the Sega franchise. So, we stick this in here. And as Sonic the Hedgehog says, let her rip. And let her rip. This is going to be messy. I need plasticine. Give me a sec. This is where PowerTac TM, apparently, is useful. Thank you, PowerTac. Let's just see if this actually works. It kind of does. I need to slow it down a little. Okay. Now, I don't know whether you can see it, so I'll try to... So I don't know if you can see it. Cameras are kind of messy for this sort of stuff. You really do need... Hang on. Give me a sec. There we are. Can you see that? Can you... Oh, sorry, I need to... There we are. That's a Zoetrope. Hang on. There we are. That is a Zoetrope. You're very, very welcome for this history lesson. This has been Sofox with our history lesson. I mean, Arduino program. I think I'll end on a high. Thank you. Thank you and good night.